Hello, folks. How's everybody doing? I hope you're doing better than me. I just came out of the hospital a couple hours ago, and I thought I'd put you up to date. Been in there like 11, 12 days now. Great week, great couple of weeks. Trying to get rid of a bacteria that struck my leg, my lymph nodes. It's a bacteria that attacks the lymph nodes called erysipelas. They say Queen Anne uh, during the 18th century she died of this, and apparently Richard Wagner, the musician, German musician, he also had bouts of erysipelas. Thank God for antibiotics. But I'll be on antibiotics for at least another couple of weeks probably. This is what my leg looks like today. A couple hours ago, I took a shot, and you can see it's still red and kind of dark in the ankle. So I still have some ways to go. And this third time I get this in 6 years, so I know it well. I know when I get this stuff, your lymph nodes start hurting and they get bloated. I got to rush to the hospital because within a couple hours, start vomiting and losing my mind. Some people would have probably preferred that I did never come out of the hospital. I had some comments before I left. I want to go over some of those and then go into the electric universe, the hopefully the final part. And one fellow, his name is Gil B, and he says, Bill, your theory is irrational. You are not using physical ropes. Whoa. You're not using physical ropes. Physical ropes aren't visible, nor can a person walk through physical ropes. Huh. And so he says it's completely irrational to expect anyone to understand the type of rope you're claiming exists. Looks like I ran a little bit out of focus there. There it goes. I don't know why I have that problem with this camera. It's completely irrational to expect anyone to understand the type of rope you're claiming exists. Your ropes are invisible like gravity and the atom, yet they physically restrain all things. Then he puts into parentheses, except stuff like helium, which is impervious to your ropes. I have no idea where he got that. But can be walked through as if they don't exist. Now there's a comment for you. What's the problem with what Mr. Gill is suggesting? Well, he's invoking the word physical. He's invoking the notion of the word object that of ordinary speech. That's what it is. He's not using the scientific version. Okay, so what is the scientific version? The scientific version is an object is that which has shape. That's it. Very simple. And what is Mr. Gill referring to? He's referring to the touch and see version of the word object. He thinks something physical is that which you can touch and see. And so this is a question of definitions to begin with. And the first thing we have to notice is that not all objects can be seen and touched. You see a circle, but you can't touch it. You can touch the paper, you can touch the ink, but you're not touching the circle, or a square, or a tribar, supposedly a three-dimensional entity imprinted on a two-dimensional platform. So you can see it, but you can't touch it. And for sure, we cannot see the air because we can touch it, we can run our hands, but we can't see it. And fortunately, Mother Nature was a little wiser than Mr. Gill because she said, if we could see the air, that's all we would see. We wouldn't see the walls, we wouldn't see rocks, we wouldn't see trees, we wouldn't see anything. All we would see at all times would be the air. So we can't see the air, we can't touch a tribar or a cube, perfect cube, ideal cube. So that is not the universal property that all objects have. Now it's interesting that I've been dealing with this for 20 years. I think I'm pretty much an expert on the word object. I heard it all. And one of the things you'll find, at least throughout the record, is no one has ever approached me and said, "Bill, what does the rope smell like?" Huh? Yeah, I mean, what odor does the rope have? Huh? What taste does it have? What does it taste like? Is it like salty or sugary or sweet, vinegary? Huh? Can we hear the rope? Can we go to the lab and maybe twang it and find out what kind of noise it makes and to detect its presence? Huh? No one has ever come to me with hear, with taste, with smell. It's always they're obsessed with touch and see. They just want to touch and see things. We're so used to touching and seeing everything every day that when someone brings up something, a theory of this nature, and proposes, like in my case, a rope, they say, let's go to the lab and let's test your theory. And what they want to test is the touch and see properties of the rope. And it turns out that, Mother Nature deliberately made all her invisible stuff, all her invisible mediators and agents, she made them invisible and intangible. And they want to test the tangible, seeable, visible properties of what by its very nature is intangible, unseeable. So no, an object is not that which we can touch or see. An object is that which has shape. When I say that Mother Nature is using a rope to do her fancy footwork, her invisible, workings, I'm referring to the shape, only to the shape. It doesn't mean that we can transfer or extrapolate the properties of an ordinary rope that you buy at the hardware store to what she has, what she uses every day. We only have the shape. It's just for you to get an idea of what shape this invisible thing has. It doesn't mean it has all the other properties. Here I have a thread. In fact, it's two threads. I hope you can see that. Okay, it's a black and white thread. I tangled them around a little bit so that they can, you can see some contrast between them. Okay, that's a thread. And I'm saying that all that exists out there in the universe is a single thread. It's a closed loop thread. You can imagine it as a circle, as an oval. It's very lengthy and very thin. Talk about spaghetti. This beats spaghetti by a mile in every sense, in length and in thickness. It's very very thin. That's the proposal. Now, does that mean that I'm going to extrapolate the properties of this thread that I use for sewing, buttons? Am I going to extrapolate the properties of this 3D thread onto her world? No, of course not. Uh, this thread, if you look at it under a microscope, especially if you go deeper, like with an atomic force or scanning electron microscope, you're going to get to the point where you see molecules, maybe even some atoms. So it's made out of parts. So this little thread is like a robot. It's got all these joints and it moves. It wiggles and it's flexible because it's got all these joints. The joints are the atoms, the molecules, right? And they're independent entities that build this thing we call the thread. Okay. The thread of Mother Nature's thread. Listen carefully now. Mother Nature's thread is not only long and extremely thin. Nothing in our world even manages to get close to how thin the thread is. But there's two properties. And for this, you got to sit down because this is where the problem is. The thread is made of a single piece. It's a single piece. It's not made out of parts. and it is flexible, made of a single piece and flexible. We've never even heard of anything like that in our 3D world. And that, already a lot of people say, oh, you're bringing ghosts into the discussion. No, it's not that I'm bringing ghosts and spirits. I'm trying to imitate what she has. And the only property I'm going to introduce is shape. I'm going to say that what she has out there is a very lengthy, very thin thread. Or maybe it's Father Universe, whoever. It's a very thin, very lengthy thread. But it has two properties which are counterintuitive in our 3D world, which is it's not made out of parts, yet it's flexible. Because typically something that is not made out of too many parts at least gets more rigid and more rigid. If it's made out of a single piece, we imagine it completely rigid. And that's not the case here. And again, we have to imitate her world, not ours, not the one we want. And that's where people find, a little problems, a few of the problems. They have trouble accepting these assumptions. And that's what they are. They're assumptions. Okay, we have to imitate her rope. We have to make it invisible. We have to make it untouchable. We cannot prove the existence of the thread or of the rope by going to the lab. There's no experiment you can run. The only way to approach the thread, the only way to approach the rope, pulling back, close your eyes, and use your mind. Use your brain. You have to visualize. That's all you can do. Okay? That's why no one ever zeroed in or came across the notion of a rope, because nobody imagined that there could be something, a thing, something which has shape between two atoms, and that you can go right through it, that you can't see it, you can't touch it, you can't do anything with it. And so that's why no one came across this. And everybody said particles. But we can turn this around. Here, let me show you. Just let me put this up here. Okay, so we go over this one more time before I move on. Gills the smart, he says, object, that which you can touch and see. So he wants to use touch and he wants to use vision. And he says, oh, you're saying that the rope is equal to the ordinary hardware store rope, right? Is the same as an electromagnetic rope? Yeah, only in shape. Only it's in its architecture. Only there. That's where it stops. Other than that, a rope of everyday life is made out of atoms. It's got many parts to it. This rope only has two threads, and each one of those is essentially the same thread. It just goes around the universe and back here. And that thread there is made of a single piece, and it's flexible. So you have to make those assumptions. Okay? Can we touch a tri-bar? No. Can we see the air? Hopefully not, because that's all we would see otherwise. What am I suggesting instead? I'm saying that the rope only matches the ordinary rope that you find in your hardware store, only in its shape, only it's in its architecture. You can't approach it through the senses, vision, hearing, smell, taste, or touch. You can only approach it through the mind. Okay? And unless you buy into that, not to believe, to understand the theory. Okay, let's keep that in mind. We're not trying to twist your arm here. We're saying I'm going to explain to you a mechanism with this rope, with the threads, and I'm going to show you mechanisms of, all the invisible mechanisms, magnetism, electricity, gravity. I'm going to show you the mechanisms, how it can be done with a rope. Okay, and what we're trying to say here is that you cannot go to the lab and test that in any way. You cannot find that there is a rope there. Okay. Now, anyways, if you got to put something in there. What are you gonna put spirits instead of light? Is that how we do light? Do we do gravity with spirits? Or is there some invisible, untouchable object that is operating in that region? That's what you got to decide for yourself. If you want to believe in spirits, fine, but physics is done with objects. If you have a magnet that's going to have this Or let's even something simpler that probably to imagine, a coil. You have a live coil. Well, we know that there's a force going through the center of the coil. You don't see anything. You can put your hand in there, maybe you don't touch anything, but that force, whatever spirit is in there, has the ability to move some things in there. We call it the electromotive force. And so, is that force not mediated by some kind of object, or is it a spirit? Is it some kind of angel, or what is it? This is what we have to figure out. And so you got to put something in there. And you might say, well, I'm not going to do it with things. Well, that's where you run into trouble, because then you're not doing physics. You're doing religion. You're saying you're going to be introducing spirits. You're going to maybe introduce... well, not true, Mr. Illyrian. Belief and knowledge is defined as justified true belief. So knowledge and belief are actually synonyms. But yeah, the issue here is that you're not going to prove the rope to yourself or to anyone by going to the lab, because you're not going to be using the senses to detect it, or some other apparatus, or some device. The only way to approach the rope is think, visualize. That's the only way. And what we're looking at is the mechanisms. Can we explain mechanisms with a rope, with a single entity? That's essentially what classical mechanics and later quantum mechanics try to do. They try to explain light, gravity, all these things with particles. And then they gave up on that. They said, we can't explain with particles. That's where we are today with particles. So particles cannot explain it. The rope can explain it. And all these invisible phenomena. Okay, let's move on here. We have another gentleman, and he was a lot kinder. He says, damn, Bill, I know you're getting dumber by the day. Your a number of reasons of science is hilarious. I'll just pick one. Observability, for instance. You say it isn't science, so in that respect, a blind man can be a scientist. Correct. A blind man can be a scientist, right? Dude, if you can't observe it, how the hell would you even know it's there? If you can't see to observe something, how the hell would you even know it exists? Well, there's a lot of words that he's used there. All of them are objected to by rational science. And here's the list one more time. And let's see if I can make that a little smaller. Okay, and so what we do before the conference, you can do anything you want before the conference. You can observe, you can measure if you want, you can do calculations, come up with equations, you can do experiments, you can demonstrate to your friends, family, to yourself. These are things that you do before the conference to get ready for the conference. After the conference, you might do some arm twisting. You might try to do some politics and try to persuade and convince people. You might develop some technology. If you're a good boy, they might give you a prize, You censor your opponent's theories. You vote for theories. All this stuff comes after the conference, got to do with politics, with religion. At the conference, what we do is what is called science. And science is only explaining a mechanism. You explain the mechanism objectively so that people understand the mechanism and then just leave the room. Okay, the purpose here is to understand how Mother Nature runs her shop. That's what we're trying to figure out. So we go to the conference, someone explains in his way, his theory, and the best way to explain is making a film. You watch the film and you understand it because you just watched, the whole mechanism in front of your eyes. And it's the invisible stuff we have problems with, like I always give the example of the magician. He cuts the lady in half, or maybe, pulls a pigeon out of his handkerchief out of nowhere. Well, you can describe it and say, yeah, he pulled the pigeon out in 10 seconds, and we don't care about the objective, just what you saw. We want to see the invisible stuff that the magician did, how he hid the trick from you, how he put a veil to your eyes and did not allow you to see how he did the trick. That's what we want to understand from Mother Nature. We don't want just a measurement and the calculation and an equation says, okay, I describe how fast a lion runs. So, is that science? Just measuring and calculating and coming to the conference and putting an equation up there and says, I've got a more accurate equation than you do. See, mine is more correct. We still don't know how a magnet attracts another. We still don't know what electricity is, how it works. We don't know what gravity is. We don't know what light is. So what's the point of doing 400 years of mathematics and not understanding a single mechanism today? I mean, that's what people want to know. The common folk, they're not interested in equations. They're not interested in how accurate your measurement was. They want to know how a magnet attracts another, and then they go home. They want baby stuff. They want kindergarten stuff. And, a lot of people say, well, how can you tune that into kindergarten? It's so difficult. No, it's not. I keep telling you, you got two magnets, two pieces of metal. That's it. Now, how difficult can it be to figure out how one piece of metal attracts another? This has to be kindergarten stuff. Mother Nature never went to college. She never even went to high school. She's doing kindergarten stuff all her life. She just moved asteroids and other rocks in the universe around. And maybe that's Father Universe, I don't know. This has to be simple. It has to have a simple answer, and the only thing you have to figure out is what invisible stuff is between the two magnets. That's it. So yeah, physics is simple once you make the invisible visible. Once we see how the magician did the trick, it's a piece of cake. You say, that's how he did it. Yeah, until you know that it's a mystery. It's, how was this trick done? This was true black magic. It's witchcraft. No. The guy does a trick, he veils it from your eyes, and you haven't seen the invisible part of his trick. You saw just the visible part. And that's why it's so mysterious. And once, he shows you the trick, it's child's play. You say, oh, gee, if I would have known. Okay, so here's the issue for these gentlemen, both Mr. Awake and Mr. Gill. And what entity are they going to simulate light with? Are they going to use particles, waves, rope? What do they propose we do light with? They got to put something in there. They might say, like a lot of people out there say, well, it's the undulation of nothing. Okay? So the first question is, why did they put waves in there? What are those vectors? The blue and red vectors that they put for waves, what are those? Those are just values. Why do they illustrate them if they're illustrating numbers? That's what they're illustrating there. They're putting numbers in a different format. They're saying, well, that's a vector. That's got magnitude and direction. That's all they're doing with a wave. Then they're moving the wave, and it gives you the impression that you're moving something when all they're doing is describing mathematically something and illustrating it with this ridiculous device which they call a wave. Okay, but are we going to do it with nothing? A lot of people say, well, it's the undulation of nothing. There is nothing really there. It's the only light. They say that light is the only thing that doesn't require a medium. And that takes us back to spirits. They're doing science with spirits. And let me tell you what the problem with nothing is. Here's a summary of what the problem with nothing is. To use nothing, okay? First, they never defined it scientifically, okay? We don't have a scientific definition of the word nothing. Nobody knows what nothing is. Everybody just says, well, it's not a thing. But that's an antonym. You can't define in terms of synonyms or antonyms. Because what is a something? Is it not a nothing? I mean, how long are we going to do this? I mean, is an elephant not a dog? Is that what an elephant is? Or is it not a horse? Yeah, you can't use antonyms or synonyms. You have to use some kind of definition. If nothing is important in the discussion, if it's a key word, well, then you got to define it. And then you've got that in mathematical physics, nothing is simply stated as no thing, right? Antonym. But then you have it that nothing is full of all kinds of things. They say, well, there's no real thing as nothing because The nothing, the vacuum, space, whatever you want to call it, is full of sizzling energy and virtual particles and excited fields. It's got all this garbage in there that they constantly measure. So you go into a vacuum chamber, you pump it down. You're going to -3 torr level, -7, -12. So you're pumping it down. You're removing material from that chamber. What are you leaving behind? If you're removing the density of real particles from there, what remains behind? What are we going to call that region that now has one particle less? What are we going to call it? Isn't that nothing? And this is the issue. So right now there is no such thing as nothing in mathematical physics. To say that that a wave is the waving of nothing, you're not saying anything, pun intended, because there is no such thing as nothing in mathematical physics. It hasn't been defined, and then they fill nothing with all kinds of garbage. They say, well, there's no such thing as nothing. There's no such thing as a vacuum. So what is it that vibrating? We're back to square one. What is it that's vibrating when we talk about light? What is that vibration, that those vectors that we see moving in there? And you might say, well, because it goes to the properties of touch again, yeah, it's particles. But see, no one ever asked, what if we shoot particles like bullets? If we're going to simulate it in the lab, we shoot bullets from two guns. Okay? Machine gun here, right? Perpendicular. Okay, they're perpendicular to each other. And we shoot bullets. Will those bullets go through each other, or will they hit and ricochet and bounce off some of the bullets? So you cannot prove with particles, with classical particles, you cannot go to a lab and prove the existence of particles underlying light, because you're going to run into the same trouble as with a rope or with anything that you bring from the real world. I mean, I don't care what you want to simulate light with, or gravity with, for that matter. Whatever you're going to use from the 3D world is going to be tangible. And if you're going to try to imitate Mother Nature's intangible world, you certainly can't do it with tangible stuff. So does that mean we can never simulate Mother Nature's world because everything is tangible in our world, or visible, or most of it is? No. At some point you got to come to terms with the fact that you're going to have to use some object, some shape from our 3D world to imitate what she does, but that thing in her world does not carry over the tangible and visible properties that we have for that same object in our 3D world. That's it. That's what you got to come to terms to, that point in your thinking. You can't avoid it. So yeah, we're trying to imitate Mother Nature's world. Her agents, her simulators, her mediators are all intangible and invisible. So we can't do it in the lab. We have to do it by thinking, only by thinking. And the only property that her objects have in common with ours are the shape, not any other properties. Certainly not tangibility and visibility. Okay, we had another gentleman. He made a comment. Here it is. He said, along the same lines, really, they're all thinking in the same terms. They say, what part of your rope theory can you hand over to an engineer and have him build something that would manipulate the ropes? See, they want to touch it. They say, I want to touch your rope. I don't want you telling me about your rope. I want you to give it to me and let me touch it. We can't do that. Mother Nature, even if Mother Nature came here personally, or God, or Father Universe, they say, here's my rope. And she hands it over to you, and you're not going to see anything. You're not going to touch anything. You say, well, I don't have anything there. Well, I just gave you the rope, the one I do my tricks with. You wanted to know what I use that rope, the one that you have in your hand. But I don't have anything in my hand. Well, yes, you do, but you can't see it and you can't touch it. So I don't know. All these people think they're going to develop some kind of technology or something. Science is worthless nonsense. Science has no purpose whatsoever. Let me repeat that. There is no purpose to science. We don't develop technology with science. Science is only to understand how Mother Nature runs her shop, her invisible world. We know all the visible stuff. We know how a pulley works. We know how the window broke with a brick. We know what an inclined plane is, how it works. All the visible stuff we figured out a long time ago. It's the invisible stuff we're still struggling with. No one can tell you the invisible stuff because they're not simulating it with the right objects. That's why they can't tell you. And I'm saying it's the rope, and people immediately say, well, how come I can't touch the rope? How come I can't see the rope? Well, can you see the air? Can you touch a tri-bar? What if Mother Nature came here and gave you the rope and put it in your hand? Would you be able to touch it? Would you be able to see it? No, because hopefully not, because that's how her rope is. What is she supposed to do? Do some magic and make her rope visible and tangible just for you to see it and say, oh, now I believe. Yeah, it's one of those things that we're trying to figure out how she does her work, Mother Nature, and we can only do it with shapes and not extrapolate the properties of ordinary life, our 3D world. We can't transport that into her world, into her invisible world. Okay, and I had one more comment there, and that's from this fellow. Got a weird name. I call him Lula Lule, like the song Lule Lule La La La. Well, this guy's more La 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 than Lule. And he says, among other things, he says he can't believe that it's crazy that all these atoms are interconnected by physical ropes. And again, they highlight the word physical because they're thinking of touch and see. They're not thinking of shape, which is what physical means in science. In ordinary speech, physical can mean anything. I mean, they haven't even defined it. Nobody cares because it's informal. In science, you've got to define it very strictly, and we define it as shape. That's what physical means. So every time you use the word physical, we're not talking about touch. We're not talking about see. And this is what these people have in mind. They're still thinking in ordinary terms. And then he says this number of combination would be unimaginably huge. So who cares? First, the universe is unimaginably huge already. We have unimaginably number of stars and galaxies and who knows what. But that's not the point. The point is that, if we do this with particles, we got more particles than ropes. Because the rope at least is elongated, made of a single piece, right? In other words, the thread is. But imagine if we were to chop that into little pieces and call them particles. Obviously, we would have many more particles than we have ropes out there. So if anything, I've reduced the volume of entities, you could say, out there. With particles, you're going to have, nobody's ever asked how many particles there are in the ether. The ether is this vibrating group of particles out there that supposedly is light. Has anybody asked how many particles are in 1 centimeter of ether? Nobody asked those questions. But then here's an unimaginable number of ropes. So what? I don't even know why that's an issue. And then it says all matter in the universe is interconnected. So no problem there. Yeah, that's the point. But he says it's connected through etheric plane and consciousness. So he's introducing concepts. He's trying to do physics with concepts. And that's a no-no. We talked about that in the past. And here is a little bit of that. Is this? What we call irrationality, okay? And you can see where he goes wrong. He goes wrong already on the first step. He's trying to do physics by reifying concepts. He's making something that is abstract into something that is concrete. So he wants to do so-called science, so-called physics, by using consciousness, a concept. So what is consciousness? Can you bring a little bit of consciousness and put it on the conference table so that we can all see it and see it from all around, see what consciousness looks like? And so these people don't realize when they're using these words that they're using concepts, especially words like energy and field. They're concepts. You can't do physics with concepts. You cannot move love and say, oh, I just moved love. Not in physics. That's okay in religion. You can, or poetry, you can use all those figures of speech and poetry and whatnot. But in physics, you can't use that. It's simply forbidden. Okay. So that gives you a little bit of a glimpse of what's going through the minds of some of the people who come around, and they have these ideas that an object has to be tangible and visible. That is not the case. An object is just that which has shape. We don't use science for anything. We don't use it to make gadgets. Okay, that's technology. We do that by trial and error. You don't have to understand what you're doing. All you have to do is do something over and over until you get it right, and then you patent it and you make some money. It's got nothing to do at all with science. And then you have people who move concepts, and they think they're doing physics, and they're not. They're moving abstractions. If anything, they're doing what I call abstracist or abstracism, not physics. Physics is something different. Physics, you move objects. You have to have objects. The first thing you have to present in your presentation, in your dissertation of physics, is the objects that are going to simulate the mechanism that you're going to show. And it's got to be objective. I should be able to watch the movie and say, okay, I understand just by watching the movie what mechanism you're proposing. That's it. And that's as simple as it is. And it's important to understand that all we need to do to finish completely with physics, completely with science, is figure out the invisible stuff. Once we figure out the invisible workings of the universe, of Mother Nature, of God, if you want, whatever, we're done. We're finished with physics, because now we understand how the universe runs. Okay? And so we're that close because we only have like 5 or 6 things which are invisible. Again, it's light. We don't know what agent mediates light. We don't know what agent mediates magnetism, gravity, electricity, and the workings of the atom. You know what the atom really looks like. Once we figure these invisible things, we're done. We understand the entire universe, how the entire universe works. And that's the only thing we don't have today from mathematical physics, at least, or from the dissident groups such as the electric universe. And I'll go over that in a second here. Okay, so electric universe, we left off the other day. What are they into? Well, they like to do this stuff. They like filaments. They're into filaments. Okay, they think all these filaments. This is essentially something from outer space, pictures or a movie of the night sky. Okay, and they say all those lines that you see there, all those bright lines. They say that's electricity. What's the problem with that? Well, the problem is that in order to have electricity, you need atoms. You need to ionize something out there, especially if it's a gas. You need to ionize a gas. Very difficult to ionize a bar of steel unless you turn it into some kind of liquid and later into some kind of gas, and then you get the electrons to pop out using the quantum mechanism, right? Okay, so what are the problems? Well, the first problem is that there is at least not 10 to the minus 3 torr out there in the universe, especially intergalactically, to produce the environment necessary to do electricity. Okay, that's where the electric universe just dies completely. You don't have enough matter between galaxies to produce this. So the question is, how do they intend to produce intergalactic, those filaments? If that's what those filaments are. If they say it's electricity, what's in between 2 galaxies? What's between 2 stars? Is it a bunch of gas? Is that what they're saying? They're ionized gas, which we don't even know how it's ionized, but we're saying that's ionized gas? No such thing. And, again, the Apollos measured the environment around the moon, and you could say even the solar wind, which is a bunch of garbage that includes the magnetic field of the sun, particles, etc. And they measured it in a 10 to the minus 11, 10 to the minus 12 torr, which is a very, very high vacuum, low pressure. There's hardly anything there. Certainly you cannot create a current with that kind of high vacuum. You cannot create it. You don't have enough matter. And that's assuming you could ionize it. The question is, how would you ionize something so far away from the sun and keep it ionized to maintain a constant current? So all this is just hocus pocus that the electric universe invented without justifying any of it. But it doesn't stop there. The real problem is the planetary atom. See, the electric universe is simply a branch of quantum mechanics. That's what it comes down to. And quantum mechanics doesn't have an atom, and so the electric universe doesn't have an atom. And because they don't have an atom, well, then their electric gravity is absolute nonsense. It just doesn't work. And so let's go over that. Let's go with start with the atom. Here we have the electric universe atom. Okay, I went over this a little bit the other day, so I'm going to go kind of quick now. What's the big issue here? The issue is that you have the planetary atom. That's the one they propose, which is quantum, and they have this electron there, which I labeled as E1. Okay, and I painted that area green because I want people to tell me what binds the electron bead, that E1, to the proton, red proton, or the blue proton, whichever, in the center of in the nucleus. What keeps the electron bound there before it is ionized? Why does the E1 go around, circle, orbit, or whatever the nucleus? Why does it just spontaneously leave? That's the only question that anybody needs to answer in all of quantum, in all of electric universe, and anywhere anyone who calls himself a dissident. That applies also to the John Chappell group. They do stuff with ether. Well, I want to see their atom. That's what we want to see. We want to see their atom. And when they show us their atom, we want to see what binds the electron to the proton. That green stuff, that's the whole problem right now with anyone using the quantum atom. Okay, so that's where we stand on this. Okay, and so what do they propose? They propose the following. They say that there's something called a force. Okay, here it is. And they just essentially move their magic wand and they say, well, there's this electromagnetic force, whatever that is. I mean, they could have said X. It's X. So what is X? I mean, what's the mechanism of X? And see, they just keep talking. It's a two-way force. It's attractive and repulsive. It's long distance. They describe it in many ways, but they can't tell you how that force works. I mean, they're in the same boat that Newton was, who said, I have no hypothesis. I don't understand how gravity works. All I know is that it does. I can describe it. Here's the math, but I don't know what the mechanism is. And I like it at the end. We just do not yet fully understand this all-encompassing role of the electromagnetic force. No, you don't understand it at all, and you never will. You never will, because nobody's researching this kind of stuff. Everybody just talks about the electricity, all the electricity that's flowing around in the universe. Nobody tells me what their atom looks like. And if their atom is made out of beads, how can you produce a continuous current as the electric universe proposes, and which we're going to be doing gravity with? Okay, so here we have another problem with the atom, and that's that you can see the p orbital, which is the guy that's describing the figure 8. I hope you can see that pretty well. And it approaches the nucleus. In fact, in this case, it goes through it. Sometimes it's just shown that it goes near the nucleus. And the question is, why doesn't it get stuck to the nucleus if one is negative and the other one's positive? And so they do this with magic. They just say, well, it goes close to it and then just keeps going. This is the region where we can find the electron bead. And that's it. There's no justification for why the electron doesn't get stuck to the nucleus. And it doesn't stop there. Here's their other version, because this is how they're going to be explaining gravity. This is their starting point. They say it's a basic principle of electrostatics that like charges repel each other while opposites attract. What do you mean it's a principle? What's the mechanism? To say that like charges repel, what are you saying? You're saying that a negative chases away a negative and a negative attracts a positive? What have you said? What's the mechanism? What's the physical mechanism? You haven't said anything. All you did was regurgitate what they brainwashed you in high school, saying, oh, positive attracts negative. And you don't even know what positive is, what negative is. It's just good for the test. You pass the test because you subtract, -5 from +6. What have you done? What have you explained with this? And so they go through this and they say, says further down, it says, but the electrons in their orbits around the nuclei come even closer to the neighboring nuclei. The near electrons exert an attractive force that is exponentially stronger than the repulsion between like-charged nuclei. So what's the problem with this? Well, the problem here is that these people are saying that, look, you got this electron, E1 there, okay, that I labeled, and it's farther away from the other, the positive nucleus of the other atom. And because of that, it's attracted weaker by that nucleus. And vice versa, E2 is attracted by the first atom, the positive nucleus, weakly as well. And they say, well, with this attractive force pulls the atoms towards each other. Well, we got a problem because doesn't negative chase away negative? We have a negative electron bead on the outer side of the atom, on both atoms. Don't those repulse each other? I mean, they're only talking about how the positive attracts the negative and how one electron comes closer to the nucleus and all this stuff. And nobody's talking about the electron chasing away the electron. I mean, that whole orbital, the outer orbital of any atom for that matter, any complex atom, it's full of electrons. And don't those electrons chase away the electrons of another atom that are also on the outside? So this is what they have to explain. See, they're avoiding the key issue, which is you're talking about attraction because you need to talk about attraction. So you say, well, it's positive and negative. How about negative and negative? I mean, you got two negative beads there. Don't they chase each other away? And so this is where it starts. Okay. And it's, and then we have this little issue here because you'll see this in many books, especially if you study chemistry. Okay. And they show you different molecules. And here in the first one, you see covalent bond, they say, between hydrogen and oxygen, okay, to form this H2O molecule. Okay, fine. They draw circles. You can see that H has a big circle around it. That's supposedly where the electron bead goes around. And you can see that it's sharing an electron orbital, I guess, with the electron bead of the outer electron bead of the oxygen atom. And the question is, what binds them? I mean, they're just putting it there. They're saying, look, the electron is over here, and they pair, and they're together. Yeah, but you haven't told me what the mechanism is. Other times you see what you see in the center there, the vibrating springs model. They show you a lattice, and they say, well, all these atoms, they vibrate with respect to each other as if they were united by springs. So what are those springs? I mean, they're telling you this, but I don't see the spring in the standard model of quantum mechanics. I never saw a spring in there. All I see is all these particles. No one talks about the springs. But when you go into chemistry, they talk about these springs. And then here you see the vitamin C molecule, and you can see all those little sticks that are between all the balls. So what are those sticks? I mean, that's what I want to know. Forget about the balls. We all understand pretty much the ball. I mean, we can imagine it. But what are the sticks? Those are never identified. Those are just called forces or fields or who knows what. So that's the problem. The problem is all these interconnections. And the rope, it's very easy. We do have an interconnection. There is a physical interconnection, which is the rope. Okay. In the case of water, in fact, that rope becomes the hydrogen bond, something they've never figured out. They have no idea what a hydrogen bond is. Under the rope model, a hydrogen bond is simply one rope connecting two hydrogen atoms because they only have one rope between them. Unlike with, hydrogen with oxygen, which would have more connections because oxygen is a bigger atom. Okay. So what is the problem with all this? Well, the problem is that this is where we get into gravity, electric universe gravity, okay? And this is where it gets to be a lot of fun. Now, Walt Thornhill got his ideas. He's the head of the electric universe, or one of the head honchos, at least. And he got his ideas from this gentleman on the lower right. His name is, Ralph Sainsbury, okay? And this is the fellow who came up with a lot of this stuff for the electric universe. And that's what the electric universe uses today. So what did Sainsbury come up with? Well, he says, and Walt Thornhill essentially quotes him one way or another, or rephrases him, said gravity is due to radially oriented electrostatic dipoles inside the Earth's protons, neutrons, and electrons. And there you have a little drawing of what they're talking about. They're saying, look, when the electron orbits the nucleus, again, they're talking about the planetary model, it's not a perfect circle. What you have is maybe you can apply Kepler's laws and say it's more like the solar system where all these planets describe this ellipse or this elongated circle, okay? And on one end you have the positive, and on the other you have the negative, whatever positive and negative are or mean, okay, in physical terms. And so you have this positive and negative poles, what we'll call a dipole. So now we have two poles. And then Sainsbury continues, like magnets, they're in red, I marked it in red, like magnets that are free to rotate, all the electric dipoles in protons, neutrons, and electrons line up to produce gravity. So they line up to produce gravity. What's the mechanism? I still don't understand the mechanism. Just the fact that you have, assuming they're correct, and they have this polarity, this dipole, okay? You have a negative side of the atom and a positive side of the atom, so the atom is dipoled, okay? It's got two poles, fine. So how does the proton attract the electron to begin with? We already covered that before. We have no answer to that. But now we're talking about the connection between atoms. So you have the positive facing the negative, facing the positive, facing the negative. Okay, so what is the mechanism? Again, we have no mechanism. All we have is just statements saying positive attracts negative. That's all they're saying. That's all they could come up with after 400 years of doing mathematics. And again, these guys are a branch of quantum mechanics, so they just parrot whatever quantum mechanics tells them. As long as they keep using the quantum atom, they're never going to find a solution to this dilemma. Okay. I want to point out here, good old Newton there, he got scared because the electric universe says if you were to put the Earth out into pure intergalactic space and stop all of its motions, it would have no gravity. Well, this is absolute nonsense. I mean, if the electric universe stands by this statement, it's absolute nonsense. You can see Newton's, the main part of his equation, mass 1 times mass 2 divided by distance squared. And that's his force equation. And that's how you would figure out, for example, weight. If you wanted to figure out the weight, you would use something, like the weight of the Earth versus the sun. Well, you would use his formula. That's what it's used for, okay? One of the things it's used for. And here you have weight, according to the rope model. And you can see that weight is a static concept. Weight only requires location. As soon as you take a step forward towards the Earth, your weight changes instantaneously. It changes instantaneously because remember it's mass times mass divided by distance squared. If you change the distance, either making it longer, the separation longer or shorter, you immediately change the force, you immediately change the weight. Why? Under the rope model, we can see why. If you have something very far away, all the ropes come together and act as one. As the box, in this case, approaches the Earth, the ropes fan out, and now you have more and more independent ropes acting on the box. That's why we have an acceleration. But the point here is that you can take a snapshot of the box anywhere around the Earth as it falls. At that point, it's got a given weight. There is no motion. So this nonsense that they say here, that if motion, if you were to put the Earth out into pure intergalactic space and stop all of its motions, we would have no gravity. This is absolute nonsense because weight is, gravity for that matter, because weight in this sense is gravity, is a function of location, a static concept which requires no motion whatsoever. That's what Newton's equation says. So unless you understand that, you're going to make this error. This is a gross error from the electric universe. Okay. What else does Mr. Sainsbury say? Well, he proposes the following. He says, regarding the interaction of the planets to the sun, this is where he's going to explain how gravity works in a solar system, right? This requires an additional dipole, okay, whatever. And it says the Earth's dipoles are oriented with their positive pole on the outside. Okay, I try to illustrate there. The positives on the outside, okay, the negatives on the inside, okay. And then the outer pole of the sun's dipole is negative. Okay, so I try to illustrate that there as well. Now you would think, you would draw a conclusion from this that the sun acts as a cathode, okay? And somehow the earth acts as a anode, and because anode is the positive end of a pair of plates, and the cathode is the other side. So here, anyone would say that, anyone who's a Christian would probably say that it's the sun should be the cathode, and it's the other way around. They think of the sun as the anode. But here's another issue, and that's the issue of force. So we have the positive on one side and the negative on the other. What's the mechanism? I want to know the mechanism. And they never explain the mechanism. They just say, it is so, there's a force. So they say it's the electric force or the electromagnetic force, or, they want to show that it's an electric type phenomenon. What have we learned about the mechanism by saying electricity? We haven't learned anything, especially when, the electric universe never defined electricity, says it doesn't know what electricity is. It simulates it with a flow of beads from atom to atom. Again, very loose because everything's discrete. There's nothing connected there. And with this disconnected atom, they want to construct a connected universe. And among them, they say that it produces the force of gravity, which is continuous. And they're producing it between the Earth and the Sun, where the Sun apparently has the negative, poles sticking towards the Earth. And this is counterintuitive from a point of view of trying to figure out what the mechanism is. I mean, if electricity is the flow of beads from the sun to the earth, or the earth to the sun, either way or both ways, is this what they're proposing? Are they saying that there's this flow of particles going from the earth to the sun and vice versa? Is this their mechanism? I mean, what is electricity? Is electricity the flow of beads? Well, let's assume those are the flow of beads. How does that produce attraction? How does this mechanism of flow of beads, electricity, if that's what electricity is, and we're just going to concede that, right? That electricity is the flow of beads from atom to atom, or just the flow of electrons if they want, no problem. How does that produce attraction? See, they're saying negative attracts positive. Yeah, but you haven't explained the mechanism. Here you have, I think the red particles are negative and the blue particles are positive. And so what? How do you produce attraction? And so again, what we're missing is the mechanism, okay? And the other thing is that, as I showed, if Sainsbury is correct, and the negative side of the atoms of the sun are pointing outwards, you would think it's the cathode. And yet it's the other way around according to them for some reason. And here you can see they talk about the heliopause, how the universe works essentially on an electrical basis. And they think of it as a closed circuit, because it's got to be a closed circuit if you're going to have electricity flowing, like in this case, from the sun to the heliopause, which is like the sheath that covers the solar system from interstellar space, okay? And so you would have to have some kind of closed system there, some kind of closed circuit, where the sun, according to their description, this comes out of their site, says, in the electrical model, the sun is the anode, or positively charged body in the electrical exchange. Right now, Sainsbury said the opposite. It's the electrons are pointing outwards at the edge of the sun. So, we don't know if the sun is an anode or a cathode, but then we have the problem of the circuit. Are we saying, how is the electricity running here? How is the electricity producing attraction? Assuming this is what they have in mind. And again, you won't find any description of this in their literature. They don't go in depth. They don't go into pictures. They don't try to illustrate what they're talking about, because obviously they have a hard time illustrating whatever they're saying. They're never going to be able to. Now look at this. If you look at the bottom left there, this comes also from one of their presentations. And you can see the numbers. They're talking about very few particles. They're talking about 10 to the minus 4 particles. They're talking about uh, hundreds of particles, maybe, in the Voyager 1 that it measured as it was coming out of the heliopause or a bow shock. I'm not sure how far it went finally. But they're talking about very few particles because that's what the Voyagers measured, very few particles. And so, where is the electricity that they're going to produce with such low particles as has been measured? I mean, if they believe in measurement, if they believe that in experiments, here's an experiment that shows that there is nothing out there in the region we call the heliopause or the bow shock, the region where the essentially it's the solar wind reaches that point, and the solar wind is composed of free particles, loose particles, maybe an atom here, an atom there. It's composed of um, the magnetic field of the sun. So all this garbage put together, if we throw it all in there, still you have 10 to the minus 11, 10 to the minus 12 torr, which is nothing. You're talking about anywhere between 50,000 to 200,000 particles per centimeter cube. And that's nothing. You can't run a current with that. I challenge them to do it in the lab. I mean, they like experiments, do it in the lab. Bring down the vacuum chamber and show me how you produce a current between two plates at 10 to the minus 11. I want to see it. I mean, I've run this many years, and you can't produce a current at 10 to the minus. You can produce a current at 10 to the minus 3 torr. Okay, no problem. In fact, that's the operating vacuum level for production. Why did NASA build their testing facility in Ohio to 10 to the minus 6? Because they know there's going to be no current 10 to the minus 6 torr. What do we have on the moon? 10 to the minus 11, 10 to the minus 12. They say the solar wind is in the 10 to the 12, minus 13 level. Interstellar, maybe 10 to the minus 16. Intergalactic, they calculate maybe 10 to the minus 19. Measured by the Voyagers, you're talking about a level of, again, 10 to the minus 12, 10 to the minus 13. You can't run a current with 10 to the minus 13. I challenge any electric universer to do that in the lab. Just pump down the chamber, put two plates, see if you can run a current. I challenge you. The chip's on the shoulder, okay? Knocked it off. Gloves in your face. Do it. Show me how you can run a current at 10 to the minus 11 torr in a vacuum chamber. And then maybe we can talk about gravity. But again, you can see the failure of the electric universe for electric gravity starts at the atom. They can't explain their atom. They can't justify their atom. They cannot illustrate their atom. Because as soon as they illustrate it, you're just going to ask one question. Why doesn't the electron fly away? That's the only question I want to answer. What keeps it bound to the proton? If they cannot answer that question, they can't start their presentation. The show's over. Okay, so we'll see you, what is it, what's today? Today's Monday. I'll see you on Wednesday. I'm going to continue with this line, finish up with the electric universe, and cover a couple more subjects there that are a little troublesome. So we'll see you on Wednesday. Hopefully I'll be better by then. Bye-bye. We'll see you then.